Alright, David Can here with another question from your Hasten Harris Math SL textbook. This is Chapter 8C.1 and Question 2, Part B. In this question we're given some circles, and we're asked to state the exact coordinates of points A, B, and C in terms of sine or cosine. And we're also asked to use the calculator to give the values of the coordinates A, B, and C correct to three significant figures. Right, so this is really all about what sine and cosine mean in a circle. What we have is a circle with a radius of 1 unit, and that's the unit circle. That's what it means to have the unit circle. The unit circle has a radius of 1 unit. And if you're on the unit circle, and point A, B, and C are, then the horizontal and vertical components of that point are described by the results of sine and cosine. So for part A, for point A, there's a vertical component describing the point, and a horizontal component describing the point. And these two components are described by sine and cosine. Sine for the vertical component, cosine for the horizontal component. That means we can say that point A is the cosine, because remember x comes first, x comma y, so that's the cosine of the angle 123 degrees. And the y component is the sine of 123 degrees. That's our coordinate. If we wanted to get the exact value, we could punch that into our calculator, and that'll tell us that the point A is at the coordinates cosine of 1, 2, 3, which works out to negative 0.545, and sine of 123, which is 0.839. That means if you want to get to point A from the origin, you have to go backwards 0.545 units and upwards 0.839 units. C looks a little bit weird because we're running backwards from the unit circle, negative 35 degrees, but that doesn't actually make things any different. It still has a vertical component given by sine, and it still has a horizontal component given by cosine. So nothing here has changed. Point C is still the coordinate cosine of the angle negative 39 degrees, comma, sine of negative 39 degrees. And if we wanted to know the exact position of C, all we'd have to do is punch that into our calculator. Cosine of negative 39 degrees gives us 0.819, and sine of 39 degrees gives us negative 0.574. That means if we wanted to go from the origin to C, we'd have to go over 0.819 units and down 0.574 units. There's no surprises with B. It works exactly the same way. B is going to be the coordinates cosine of 251 degrees, sine of 251 degrees. And when you plug those in, you're going to get components, a vertical component and a horizontal component, just like before. You'll just get two values. It'll work the same way.